My name is Ankit,
My name is Brian.
My name is Shrikar.
My name is Reem.
and today we're going to explore an ambitious idea. Is Mars colonization the answer to Earth's overpopulation challenges? Firstly, delving into the technical feasibility. Colonizing Mars is a thrilling concept, but we need to make it a reality, and the foremost hurdle we have to do this is space transportation. We need advanced yet affordable spacecraft and propulsion systems that can endure the harsh vacuum of space and support human life. Thankfully, we're seeing significant advancements in this domain. Both SpaceX's Starship and NASA's Artemis program are showcasing promising outcomes in this endeavor. Secondly, we have to deal with atmospheric challenges. Once we've dealt with getting to Mars, the next big challenge is its atmosphere. Mars lacks a thick atmosphere like Earth's, which serves as a shield against cosmic and solar radiation. In fact, the Martian atmosphere is equivalent to just 1% of the Earth's atmosphere at sea level. This thin atmosphere, combined with the absence of a strong magnetic field, leaves the surface exposed to dangerous levels of radiation. And this leads to my next point, habitat construction. These habitats not only need to be resilient to Mars' extreme weather that swings anywhere from 20 degrees Celsius to a chilling negative 153 degrees Celsius, but we also have to maintain a life sustaining environment for humans and plants. The construction techniques and materials required are cutting edge and often lead to considerable financial implications. Next is life support systems. Living on Mars is not just about surviving, but it's also about thriving. Essential life support systems must be impeccable. Think of some closed loop systems, such as those on the International Space Station. These systems have to regulate water recycling, oxygen generation, and carbon dioxide removal efficiently. Essentially, we need to recreate Earth's life sustaining processes in a compact, artificial, sustainable manner on a different planet. The last thing we look at is self sufficiency. We must establish complete self sufficiency concerning vital resources. We're looking at techniques like extracting and purifying water from subsurface ice reserves and using hydroponics to grow food without soil. Energy sources, too, are extremely pivotal because, given Mars' solar conditions, solar power and nuclear reactors can be primary contenders. However, challenges like dust storms that can block out the sun for long durations of time and cold temperatures, which affect fusion reactions, could mean that effective energy storage solutions are also crucial. Now, Brian will explain the legal feasibility of colonizing Mars.
Thank you. Now, the first major question we need to ask for the legal feasibility of colonizing Mars is who or what governs Mars? Now, since Mars is a celestial body, this means that Mars falls under the governance of the United Nations Office for Outer Space Affairs. And the office has created a treaty for all celestial and outer space activity known as the Outer Space Treaty. And it serves as the legal framework that will govern Mars activities. In the article, or in the treaty, there are 3 articles that are very crucial to the colonization aspect of Mars. First is Article 2, which states that outer space, including celestial bodies like Mars, is not subject to national appropriation. This means a nation like the United States could not send up their own colony to colonize Mars for themselves. Next, Article 5 ensures that countries that sign the treaty must support those who colonize celestial bodies. This means that while the United States couldn't send up their own colonists, they must be obligated to support those who do go up to colonize Mars. And Article 6 holds that nations are responsible for the actions of their entities in space. This would help to resolve any national conflicts that might arise. So if one nation transgresses against another in space, then the colonists who transgressed against the other nation would fall under that nation's jurisdiction. So, for example, if a US colonist committed a crime against a Canadian colonist, then they would be subject to Canadian court for their punishment. However, there are other legal issues that in regards to sending people to space. For example, Article 2 again says that there are no, or a nation could not send up their own colonists, like military or astronauts, to colonize Mars. This means that we must be sending up our own colonists to Mars. As such, we are legally liable if we do not have the colonists sign liability waivers. This is because the people who we would be sending up are not government entities, as stated, and as such, they do have rights, and they must be accounted for, and whenever we are sending them up to space. Now, for the operational feasibility, as stated before, we are not sending up we are not sending up military or government-sponsored individuals. As such, we will be sending up our own colonists, and as such, we must train them on our own. We must prepare the colonists to live on Mars for extended periods of time. This will take a lot of time and training to cover every possible situation that might arise on Mars. Say there's life support damage. Say there's a storm that comes in and blocks out one of the energy sources. Say they run out of food. There are so many issues that must be accounted for that it is almost impossible to cover every single situation that might arise in a reasonable amount of time. Furthermore, there are other issues that might arise with having to train the people for so many things to account for. If one of the colonists were to die with all the knowledge of what they specialize in, then it would take forever for another colonist to pick up that whatever that colonist specialized in. Furthermore, continual communication between Earth and Mars is essential, of course, since the colonists are not on their own. They would need the help of people back on Earth. However, because of the distance between Mars and Earth, even at light speed, it takes about 20 minutes for a direct line of communication to occur from Mars to Earth and back to Mars. As such, if an emergency occurs, then at the earliest, 20 minutes is the amount of time it will take before some professional back on Earth would be able to respond to that emergency. And if they are in dire need of resources, it would take even longer than that for resources to arrive to help them out. As such, operationally, it is most likely not feasible for colonies to deal with overpopulation on Earth. Next, Srikar will cover financial feasibility.
Thanks, Brian. Well, the idea of inhabiting the red planet is very captivating. You must talk about the financial aspect that presents a significant challenge that demands careful consideration. Let's explore the key financial hurdles associated with this futuristic endeavor. First, we got to talk about the cost-intensive interplanetary travel. Now, developing a spacecraft is not cheap for the most part, and developing it is a costly endeavor. For example, the esteemed Massachusetts Institute of Technology, or MIT for short, estimated that a Mars mission would require an investment of $4.5 billion for the development of 15 Falcon Heavy rockets for just one leg of the journey. Now, with mass-producing rockets for Mars colonization, it's currently impractical due to their exorbitant production costs. This limitation poses a substantial barrier to the swift and efficient transportation to materials and people to the red planet. While commercial rocket ships designed for civilian transport could offer a more manageable budget, this approach would likely to extend the timeline required to relocate a substantial population. The balance between financial viability and the scale of the mission remains a critical consideration. Now, from Elon Musk, who is the CEO of SpaceX, he envisioned a progressive plan in order to transport about approximately 1 million people to Mars over the span of a century, coupled with the anticipated cost reductions. Now, what's his strategic proposal, you may ask? Well, he underscores the importance of gradual and sustainable development within the constraints of a realistic budget. Another way we can manage to support this financial endeavor is with the support of the government. Now, the achievement of this cost-effective space travel to Mars necessitates substantial government support and potential subsidies. Such initiatives could alleviate the financial burden and pave the way for more affordable exploration and colonization to help provide for the overpopulation of Earth. Now, one thing that you need to talk about is the cost of a biodome. Now, you might ask, what's a biodome? A biodome is essentially a center of it's in the area that you put in Mars that you use to develop for human sustainability so that people are able to breathe in the air, have materials, have homes. They're just able to live on the planet of Mars since the conditions there are not as likable as Earth. Now, the crucial infrastructure of biodomes are vital for sustainable human life on Mars presents its own set of substantial costs. With the looming threat of inflation, the budget for these biodomes could potentially escalate, further complicating the financial landscape of this colonization project. Now, one challenge that can also happen is considering the mammoth scale of the Mars colonization project, the estimated overall budget could reach into the trillions of dollars. However, the current limitation in resources pose a critical obstacle, emphasizing the need for prudent planning and resource management in order to make this vision a reality. Although the financial feasibility is not as what we intended to be with our current economy, we still hope that we can make this mission a lot more feasible in the future, considering the cost of more cost-efficient materials that allows us to be able to transport people and resources over to this new planet in order for us to create a more sustainable way of solving the overpopulation that may happen on Earth. Now, to talk about environmental feasibility, I hand it over to Reem.
So, when we discuss the colonization of Mars as a solution to Earth's overpopulation issue, we're going to need to ask ourselves if we're going to do more harm than good. The environmental impact of rocket launches and the consequential pollution that they cause has to be taken into account. Rocket launches are known to emit unforeseen amounts of harmful emissions like black carbon and CO2 that will put the Earth and its population at risk. Black carbon is not just any pollutant. It can cause lung diseases, infiltrate our atmosphere, deplete the ozone layer, harm ecosystems, impact agricultural practices, and accelerate climate change. The exhaust from these rocket launches contains more than just the black carbon, though. Launches also emit greenhouse gases like CO2 and H2O, which trap heat and contribute significantly to global warming. The more rockets we launch, the more we risk adding to the growing problem of space debris. These are objects that stay floating in space, and over time they become potential hazards. Given these challenges, if we ever aim to safely transport people to Mars without further damaging Earth to solve our overpopulation issue, we'll need, we'll need new, more eco-friendly modes of transportation. Otherwise, we might be inflicting more harm than good on our planet. Some might argue that fewer launches would mean lesser harm, but even if we limit ourselves to a few rockets, studies suggest that we could still be risking ozone layer loss at levels deemed unacceptable by international standards. Overall, while we while the idea of colonizing Mars is fascinating, it's vital to remember our responsibility to Earth. Based on our current technology and practices, it might not be the most feasible solution to Earth's overpopulation problem. Thank you. Here are references.